14. Balance each reaction below and write a cell schematic representing the reaction as it would occur in a galvanic cell. And then we have this equation. So we have SiO32 minus aqueous plus Mg solid yields Si solid plus MgOH2 solid. And they want us to balance it in a basic solution. Oh no. Well, strap in your seatbelts, ladies and gentlemen. And we're going to go for a ride. Okay? So we need to balance this equation. And we need to write the schematic. So the schematic is basically just like a chemistry drawing, or maybe like a blueprint, I guess maybe we'll say in this one. So it basically will tell you what this equation is in a different way of saying it, where we don't have plus signs and we don't have yield signs, we have something else. But in order to do the schematic, in the best way possible, what we should do is we should break these into their half reactions and start balancing, because we need to find out which one is, undergoing oxidation and which one is undergoing reduction. We're only going to be able to find that out if we have our half reactions. So we're going to start balancing, and then somewhere in the middle, we're going to be able to draw that schematic. On a side note, just know that galvanic cells are spontaneous cells. Galvanic cells don't need any additional energy source to make the products. But in order to balance these, it doesn't really matter that we're doing a galvanic cell. It only matters because they said that we wanted to write that schematic. But anyway, let's start balancing. So if we want to balance in a basic solution, the first part is to always get the acidic answer. That's why we have to go and do the 8 steps for the acidic solution. Now, maybe you have done a lot of practice with acidic and basic solutions. I hope you have. But if not, these are the 8 steps for the acidic solution that if you memorize and step 1, step 2, step 3, etc., they can throw you anything and you will get the question right. So let's go for it. The first step is we want to take that whole equation and break it into 2 half reactions. What you're going to do is you're going to link up like species. So I say to myself, okay, I got a Si and an oxygen, right? I got a -2 charge here. So I look on the other side and I say, which one does it link up with? Well, here's the silicon. So these 2 will go together. So that only leaves room for magnesium, Mg solid, to link up with magnesium and OH. So these 2 will go together. And now I'm just going to write it. So it doesn't matter which one I write first. So maybe I'll do SiO32 minus, and maybe I'll add the states in this case. So SiO32 minus yields Si solid. And then I have Mg solid yields Mg OH2, and that's a solid. Okay. So all good here. Let's now go on to the next step. The second step is we have to balance all elements except for hydrogen and oxygen. So I can't touch hydrogen and oxygen, but I can look at other elements. So for example, I have 1 silicon on the left here. I have 1 silicon on the right. So that's already balanced. And then for the bottom one, I already have 1 magnesium and I have 1 magnesium. So that's balanced. Notice how I do both, step number 2 for both equations, and then I'm going to do step 3 for both. It's just easier that way instead of doing all the steps for one and then going back. Notice how I don't look at the oxygens or the hydrogens because that's not this step. So step 2, we basically kind of skipped over it because it didn't have to be done. Now step 3. Step 3 says, okay, now we can balance the oxygens. We're going to do that by adding hydrogen. So the rule is if you need 1 oxygen, you will always add that in terms of 1 H2O. So if you need 2 oxygens, you'll add 2 H2Os. 3 oxygens, 3 H2Os. So let's go to the top. Looks like I have 3 oxygens on the left side. I have no oxygens on the right side. So I'm going to add that in terms of 3 H2Os because I need 3 oxygens. No oxygens on the left side, but on the right side, I have 2 oxygens. So seems like I have to add 2 H2Os on the left side. Okay. And now the oxygens are balanced. We're almost halfway through the acidic solution. Next step is we want to balance the hydrogens. We balance those hydrogens by adding H+. And please do not forget the H+, because that's what makes it acidic. If you're looking for 1 hydrogen, the rule is that you will add it in terms of 1 H+. So if you want 2 hydrogens, you need to add 2 H+. 3 hydrogens, 3 H+. So no hydrogens on the left side, but on the right side, I have 3 times 2. So I have a total of 6 hydrogens. On the right side, I have none over here. So in order to balance it, I'm going to add the 6 H+. Let's do the same thing for the bottom. On the left side, I have 2 times 2. So I have a total of 4 hydrogen. And on this side, I have 2 hydrogen. So if I have 4 on this side, I have 2 on this side. Seems like I have to add 2 more on the right side. So plus 2 H+, and we're halfway through the acidic answer. Let's go. Step 5. We have finally balanced all the elements, but now we have to balance the charges. So this is where we're going to now add electrons, and electrons are E negative, right? Electrons are negative, and we're always going to add them to the more positive side. So what I like to do is I like to just make a little break here, just to give myself room that says, okay, anything on here stays on the left, anything on here stays on the right, and, for the bottom reaction as well. And what we're going to do is we're going to find the total charge on the left and the total charge on the right-hand side. Well, how do we do that? Well, all we have to do, after I move this a little bit down, is just look for the upper right-hand corner charges. So for example, I have a plus charge here. That means that I have a +1. But I have 6 of them. I have 6 H's. So I have to times the 6 by the +1. So this would be a total of a +6 charge. Plus, because these 2 charges are coming together. And then I see that I have a -2. I only have 1 of them, so the charge will be a -2. So when I add those 2 together, +6 plus a -2 is a -4. Just kidding. Well, +4. And that's the overall charge for the left side. Let's do the same type of thing for the right. But now here, I don't see a charge in the upper right-hand corner. Same thing for the water. Whenever you don't see any charges, that means that it's 0. So 0 plus 0 is 2. Just kidding. It's 0. There you go. And now since we have the total charges, we're now going to add those electrons to the more positive side. So at a 4 and 0, obviously 4 is more positive. So I'm going to add electrons to that side. But how many? Well, you want to go down to the other number. So on a number line, 4 and 0, they're 4 numbers away. So I'm going to add 4 electrons. And now I'm going to do the same thing for the bottom one. So I don't see any charge in the upper right-hand corner for water or for magnesium. So they're both 0. Doesn't matter that I have 2 of these, because anything times by 0 is 0. So 0 plus 0 is 0. Did you think I was going to say 2? It's 0. And now over here, no charge in the upper right-hand corner. So that's 0. Plus, I have a +1, but I have 2 of them. So 2 times a +1 is a +2. And 0 plus 2 is an overall charge of a +2. add your electrons to the more positive side. 2 is more positive than 0. So I know that my electrons have to be on this side. And I'm 2 slots away from 2 to 0. So I add 2 electrons. And now I'm done with step 5. Now, step 5 is a very, very, very important step because you can find out a lot of things from step 5. The first thing we're going to do is find out which one is the oxidant and which one is the reductant. Once you have those electrons of your half reaction set into place, you can find out which one of these 4 was the oxidant and which one is the reductant. Now just know that your products are never going to be an oxidant or a reductant. And also just know that an oxidant is a reducing agent and a reductant is an oxidizing agent. So just know that your products are never going to be those. So now you have a 50-50 shot. Is SiO32- an oxidant or is it a reductant? Or vice versa for your magnesium. Now this comes from the balanced half equations. Your oxidants, aka your reducing agents, they're the ones undergoing oxidation. And you can tell that something's undergoing oxidation by noticing that your electrons are on the right side of the equation. So just look at those electrons. I have electrons here on the left side, and I have them on my right side. Since the electrons are on the right side of this equation, anytime you have electrons on the right side, that's always your oxidation reaction. So maybe I'll just put ox for this one. And which one got you there? It was the magnesium. So your magnesium is going to be the oxidant. Which means that on the flip side, the other one, because remember, products can never be oxidants or reductants, have to be the reductant. And the reductant, aka the oxidizing agent, always has electrons on the left. And looky there. And who got you there? SiO32-. So let me just bring this maybe out a little bit. And I'll put SiO32-, and that's aqueous. And now we have those answers. So that's one thing you can find out from your half reactions. The other thing that you can find out right after I put that this is a reduction, red for reduction, and maybe I'll just slide this over just a tad. Oh, I got everything. Interesting. The next thing that you can find out by having your electrons set in place is the schematic. So that's why we do a little bit of work, and then we can actually get one of the answers, and then we go back to balancing. Now, a cell schematic generally looks like this. Maybe I will make it a little bit lower. It's basically set up into 2 components. Your anode in a galvanic cell is always stated first, and anox. Oxidation happens at the anode. And then the cathode component happens next. Red cat, or cat red, but red cat. The cathode is always showing reduction. And looky here, we already said what was reduction and what was oxidation. So it seems like this equation is going to be stated first, and then the reduction one is going to be stated next. Now, these 2 species just means it's like a general term for whatever you started with to whatever you ended with. And then for your cathode, whatever you started with to whatever you ended with. So since your oxidation was linking the magnesium with the MgOH2, that goes first. Mg, solid, turned into, you could think of those brackets as like turning into magnesium hydroxide. That's also a solid. Then we have those double brackets. Let's maybe throw this over here. The reduction one was the silicon, SiO3, turning into the Si. So SiO3, 2-, bracket. And maybe what I'll do is I have to put the state, so I'll leave a little room. That was aqueous. And then silicon, solid, and you're done. Notice how in your schematics, you don't have any coefficients. No coefficients allowed in your cell schematics. It's just the bare bones of what it was. And now we can go back to our steps for our acidic answer. So, oh, and one other thing. Also, do we need platinum in this cell schematic? Usually maybe you'll see like a platinum on maybe the blue side or the red side. But that only happens when you do not have a solid on either an oxidation or a reduction side. But when I look at my oxidation, I see that I have two solids, so that's okay. And on my reduction side, I do have a solid, so I don't need to add that inert electrode. Now we can continue. Now we're going back to, our regular stuff, and now we just got to balance. So step 6, we want to balance those electrons. That just means that we just want them to be the same number. Here, I had 4 electrons, and then I had 2 electrons. I can only balance by multiplying. And you want to try to get the lowest number possible. But I can just take this and times it by 2. Because 2 times 2 is 4. But I got to be fair. I have to take that and times it by all the coefficients in this equation. So let's do that. 2 times 2 is now 4 H2O. Plus, I now have 2 Mg solids. And this will yield 2 Mg OH2. Plus 2 times 2 is 4 H plus. And now I have the 4 electrons. And once I write my new one, I could get rid of this one. So I don't have to look at it anymore. Now step 6 is done. We're almost at the end of the acidic answer. Now we want to cancel out the like substances. What you're basically doing is you're just simplifying. So I had the 4 electrons on the one side. I had the 4 electrons now on the other side. They cancel. Goodbye. And let's see, anything else that I can get rid of? Well, it seems like I can get rid of the H pluses, or at least some of them. I have 6 H pluses on the left side. I have 4 H pluses on the right side. You get rid of these by subtraction. If I get rid of all of my H pluses over here, how many are left? Well, 6 minus 4 would be 2. So now I have 2 H pluses left over. I can also get rid of my H2O. I have H2O on the left over here, and I have 3 H2O on my right side over here. If I get rid of all the 3, how many would be left over? Yeah, just 1. I can't get rid of anything else, so I have to leave everything else. And what I'm going to do is I'm just going to get rid of this because we don't need this anymore. This is donezo. Okay, I'm going to move this up. How beautiful that is. I can kind of get rid of these too. Get rid of this. We don't need these charges anymore. And now, what we're going to do is we're just going to rewrite as one whole equation. So when you add these two together, what do you get? Maybe I won't put a line here. But you group everything that's on the left side, and you group everything that's on the right side. So it doesn't matter who you start with. So maybe I'll just say SiO32 minus aqueous plus H2O. In acid base, H2O is always a liquid. Plus I have 2 magnesiums, so 2 Mg solids yields Si solid plus 2 MgOH2 solid. And that's it. Did I miss anything? Oh, the 2 H pluses. So I'll add that here. And the 2 H pluses are also, since it's a charge, it's going to be aqueous. Okay. We are finally finished with our acidic answer. So pause the video if you need to. What I'm going to do is I'm just going to erase these two because we don't need these anymore. The only thing that we need is this balanced equation. And keep in mind that this was the acid answer. And now we're going to work on the basic solution. So step 1, already done. Get the acidic answer. Now from there, we're going to add as many OH minuses as you have H pluses, and you got to be fair, you got to add them on both sides. So I scan here and I say, oh, I have 2 H pluses. So how many OH minuses are you going to add to the 2 H pluses? You add the same amount. So if you have 2 H pluses, you're going to add 2 OH minuses. But I have to add it on this side as well, 2 OH minuses. And now step 2 is done. Lastly, we have to just simplify. We're going to cancel out those like H2Os. Well, remember that when I have an H plus and I am reacting it with OH minus, what does this become? This becomes water. So 2 OH minus plus 2 H plus, that's going to become water. But how many? Well, if I had 1 H plus and 1 OH minus, I get 1 H2O. But if I need 2 and 2, I get 2. And that's what's happening here. 2 OHs plus 2 H pluses, I get 2 H2Os. And basically, this now goes bye-bye. And now since I have 2 H2Os on this side, and I have H2O on this side, they will actually be simplified. 2 waters plus 1 water is now a total of 3 waters. So I can actually get rid of this and this because it's now going to turn into 3 H2Os. So finally, my basic answer. Holy guacamole. My basic answer is SiO3, 2 minus aqueous, plus 3 H2Os, that's a liquid, plus 2 magnesiums, that's a solid, yields Si, solid, plus 2 Mg OH2 solid, plus 2 OH minus, and remember, since it's a charge, that's going to be aqueous as well. And that's our final answer. So we basically got 3 answers out of this. Let me just maybe, there you go. What? We want the highlighter, there you go. So that's the balanced equation. This is the cell schematic, and we also found out which one was the oxidant and the reductant. And now we're done. Whew, that one was crazy. I really hope this helped. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel if you would like to help us out. We're almost at 30,000 subscribers, and it's all because of you guys. Thank you for using this channel as your additional educational resource while learning chemistry videos. We also have math and physics on the channel at the moment, with more subjects coming in the future, so you could always check back. I hope you guys have a great day, and I'll talk to you soon. Bye-bye.